Hello and welcome back to my channel. This video is about principles of costing, and today we're going to practice answering some exam questions about calculating overhead absorption rates and looking at the behavior of cost. Before we proceed, let me just mention that I have discussed this topic in my previous videos, which I will put the link in the description down below. Now let's go to our example. Number 1, complete the following table showing fixed cost, variable cost, total cost, and unit cost at different level of production. Enter your figures for unit cost to 2 decimal places. All other figures must be rounded to the nearest whole pounds. So we have to complete this table. We have 3 different number of units, and we have to find out the fixed cost, variable cost, which are cost by behavior, and the total cost and unit cost. Let's start with the 3,000 units. We have the fixed cost and variable cost, so let's go to the total cost, which is the total of these two. So 66,500 is our total cost. Remember to enter the figures for these 3 columns to the nearest whole pounds. Then let's get the unit cost by dividing the total cost 66,500 by the number of units 3,000. Then let's round it off to 2 decimal places, so our unit cost is 22.17. Next, for the 8,000 units, we don't have the fixed cost here, but we know that the amount is fixed no matter what is the number of units. So this is the same as the 3,000 units, which is 44,000. Then let's go to the variable cost. The variable cost varies as the number of units vary. So the variable cost for 3,000 units is different for 8,000 units. To get the variable cost, we have to get the variable cost per unit first. I know it is not being asked here in this table, but we need it to get the variable cost for 8,000 units. To get the variable cost per unit, let's go back here in this line. In here, the variable cost is 22,500 for 3,000 units. So let's divide this variable cost by the number of units, and we got 7.50 pounds. And this is our variable cost per unit. And remember that this amount is fixed. Now let's go back to the second line. Let's get the variable cost for 8,000 units. Now that we have the variable cost per unit, which is 7.50 pounds, let's multiply this to the number of units, which is 8,000, and we got 60,000. So this is our variable cost. Let's go to the total cost. The total cost is just the total of fixed cost, 44,000, plus variable cost, 60,000, and we got 104,000. So this is our total cost. Next, let's go to unit cost. Unit cost is the total cost, 104,000, divided by the number of units, which is 8,000, and we got 13. So this is our unit cost. Next, for the 12,000 units, let's go to the fixed cost. Remember, this is fixed, so the amount is also 44,000. Next, let's go to variable cost. We already know the variable cost per unit. This is the same amount that we are going to use because remember, the variable cost per unit is fixed. So let's multiply this amount, 7.50 times the number of units, which is 12,000, and we got 90,000, so this is our variable cost. Next, let's go to the total cost. This is just the fixed cost, 44,000, plus the variable cost, 90,000, and we got 134,000, so this is our total cost. Next, let's go to the unit cost. To get the unit cost, let's get the total cost, 134,000. Let's divide it by the number of units, 12,000. Then, let's round it off to 2 decimal places, and we got 11.17, so this is our unit cost. Then, don't forget to double check all your calculations. Next, let's move on to our next question, number 2. XYZ Limited is a manufacturer of a single product with the following budgets. So this is the budget. If they use machinery instead of labor, the budgeted machine hours are 4,000. Letter A, complete the table below to show what the overhead cost per unit would be at the 3 different overhead absorption rates. Enter all values to 2 decimal places. So we have to complete this table. We have 3 different methods, and we have to get the hours per unit, OAR, and the overhead cost per unit. First, let's start with the per unit method. The figure that we can see here is either the number of units or the number of hours. Since our method is per unit method, this figure is the number of units. This is also the same figure that we can see here in the budget, here in the activity level, which is 3,500 units. Next column, the hours per unit, is not applicable since our method is per unit method. Next column, overhead absorption rate or OAR. Remember the formula for OAR, and I have also discussed this in the part 5 of my videos. So the OAR is equal to the overheads divided by the number of units. So our overheads is 75,000. Let's divide it by the number of units, which is 3,500. Then let's round it off to 2 decimal places, and we got 21.43, so this is our OAR. Next column, overhead cost per unit. This amount is just the same as overhead absorption rate since our method is per unit method. So our overhead cost per unit is 21.43. Next method is per labor hour method. So this figure here is the number of hours because our method is per labor hour. This is also the same figure that we can see here in the budget. Labor hours, 5,600 hours. We have to get the hours per unit, overhead absorption rate, and the overhead cost per unit. And we know there are different calculations required for each column. And sometimes it could be confusing or it's hard to remember which one to divide or multiply. So to make it a little bit easier, the simplest hint that we could use is this one, the heading. It says hours per unit or hours slash unit or hours divided by units. So the number of hours, 5,600 divided by the number of units, 3,500, and we got 1.60, and this is our hours per unit. This is the number of hours to produce 1 unit. Next, OAR. Remember that for OAR, we are using the formula, which is OAR equals overheads divided by number of labor hours, since our method is per labor hour. We have to always remember that the OAR formula depends on which method we are calculating. Now let's calculate the OAR. Overhead 75,000 divided by labor hours, which is 5,600. Then let's round it off to 2 decimal places, and we got 13.39. So this is our OAR. Next is the overhead cost per unit column. This is a bit tricky to remember which one to divide or multiply, but the hint here is the per unit. So the figure being asked here is the amount per unit, even if we are using the per labor hour method. Unlike in the per unit method, the OAR that we can see here is the same as the overhead cost per unit here. But in per labor hour method, our OAR that we can see here is the rate per hour, not per unit. So this is not always the same as the cost per unit because it doesn't always take 1 hour to produce 1 unit. In this example, it takes 1.60 hours to produce 1 unit. So let's multiply the OAR to the hours per unit. So remember, to get the overhead cost per unit, the formula is to multiply the OAR by the hours per unit. So let's calculate. This is the OAR that we got, and I will not round it off to 2 decimal places, but instead I will multiply it straight away to the hours per unit, which is 1.60. Then that's the time that we have to round it off to 2 decimal places because this will be our final answer that we have to enter here. So 21.43 is our overhead cost per unit. Next, our last method, the per machine hour method. The figure that we can see here is the number of hours because our method is per machine hour method. This is also the same figure that we can see here. We also have to get the hours per unit, OAR, and overhead cost per unit. Let's use the hints that I have mentioned earlier in the per labor hour method. First is the hours per unit column. So this is the hours per unit or hours divided by units. So the number of hours, which is 4,000, let's divide it by the number of units, which is 3,500. Then let's round it off to 2 decimal places, and we got 1.14. So this is our hours per unit. Next column, OAR. For OAR, we are using the formula overhead divided by number of machine hours since our method is per machine hour method. Now let's calculate the OAR. Overheads, which is 75,000, divided by machine hours, which is 4,000, and we got 18.75. So this is our OAR. Next column, overhead cost per unit. We cannot put the AOR here as well for the same reason that it doesn't always take 1 hour to produce 1 unit. So in this example, it takes 1.14 hours to produce 1 unit. So let's use the same formula here. So we have to multiply the OAR by the hours per unit. But first, we have to be careful before we proceed in multiplying. You have to remember that the amount that we put here earlier was already rounded off. Remember, we shouldn't round off until we get the final answer. But if you are wondering why we round it off here, because this is the final answer for this column, so it should be rounded off. But for the overhead cost per unit column, we have to round off when we get the final answer. So first, let's get the original figure of the hours per unit before rounding it off, which is the number of hours, 4,000, divided by the number of units, which is 3,500. Then let's proceed in multiplying this to the OAR. Then this is the time we round it off to 2 decimal places. And we got 21.43, so this is our overhead cost per unit. Then don't forget to double check all your calculations. Before I end this video, let me just give you a quick tip. We have to always follow whatever the instructions given in rounding off the figures. Sometimes it's rounding off to whole pounds, sometimes to round off to 2 decimal places. So be very careful in rounding off. Also, remember to round off on your final answer that you are going to enter in the table. Imagine if we forgot that we have previously rounded off this figure and we have multiplied this to the OAR, then we will get a different figure. So it's important to take notes as well. And that's it for today's video. I hope you find it useful. If you want to watch more videos like this, please don't forget to give us a thumbs up and subscribe to our channel. Thank you for watching.